Last lesson we looked at inverse norm and how we reverse the normal distribution curve. What we're looking at this lesson here is how we find an unknown mean or standard deviation in the question. And in order to do that we need three things, and those three things are: we need to know what the z-score is, and we do that by finding the inverse norm. We need to make sure that our mean and deviation is 0 and 1, and we need to make sure we use the z-score formula to help us find the unknown variable. Why do we use 0 and 1 for our mean and deviation is, if we look at the distribution of the axes, well, remember that we have mean plus and minus 1, 2 or 3 deviations. We can match those up with our z-scores. So generally your z-score will have a mean of 0, and it increases or decreases by 1 unit as you move across each deviation. So on the right hand side we got 1, 2, 3. On the left hand side we go down 1, 2, 3. And it's these points here that never change. Okay, just like the percentages in the curve at the top, the z-scores never change. So therefore the reason why we use the z-score, because it's a consistent way of measurement. So let's have a look at an example question that we got up here. You may get questions where it will tell you in words that you need to find the mean or deviation, or you may get a question like you've got up here where it's giving you a distribution, where it says this is normally distributed with an unknown mean but a standard deviation of 6. We also have information about the distribution of the function we're looking at here. So the function that we're looking at on this case here is something that's less than 40 has an error of 0.2. So looking at this here, we'll be thinking, well, why would I be using inverse norm here? You said in the last video we use inverse norm when you have an unknown value here. Well, that generally is the case. But we need to use inverse norm to help us calculate that z-score. So what we put into our function here, and this is important, the notation, is your tail must match the tail that you have with your z-score. And then we now put in or plug in our formula that we use for the z-score. So x is your 40, we don't know your mean, we know your deviation, and we know the area is approximately 0.2. It's from this point here that we now go into our inverse norm, so we can convert your area into a z-score. Now, let's go back into your calculator. So we're in statistics here. Remember, it's distributions, normal, inverse norm. We're now going to plug all this information in here. We know it's a left tail because it's pointing to the left. We know it's an area of 0.2 because it has an area of 0.2. It has a deviation of 6. Now, I don't want to put 6 in here because I don't know what my mean is. It doesn't matter if you have the mean, or one deviation, or you're missing both of them. If one of them is missing, you must use 0 and 1 for your mean and deviation. So your deviation here will now be changed to 1, and your mean will change to 0. And what happens here is you're going to get an answer of negative 0.84. We can check if that's correct, because 20%, less than 20% is going to be around this area here. Okay? So therefore, if it's less than this area here, then we must be at negative 0.84. So if we rewrite this formula now using just the z-score, we have 40 minus your mean over 60 is now equal to negative 0.841. And what we're doing in this case here is now we're going to rearrange the formula to find your unknown mean. So if we multiply both sides by 6, we should get 40 minus mean is equal to 5.052, I think. That's about correct. Yep. If we bring our mean across, we get negative 45.052, and then your mean is equal to 45.052. So we found out our mean. Okay? How do we know this number is correct? Well, the way we know it's correct is if we substitute your mean back up into your distribution. So we know that our distribution says that we don't have a mean, but we just calculate our mean as 45.052. So if we go back into your calculator and exit, go into our distribution, go to normal, and this time go to normal CDF. What we're going to do is we're going to find out if your mean is 45.052 and your deviation is 6, then we should get some approximately 0.2. So into our calculator here, we've got our lower, what's going to be a very, very low number. 40 is the highest. We come down to our deviation. Our deviation is 6. Our mean we calculate is 45. So we'll do 45.052. And then we get, click, enter. We get something that's very, very, very close to 20. Now because we terminated this, we're not going to get exactly the same value, but we've got something that looks very close to it. So what we have in this question here is we've found out what our mean is. And the same process would go if you find your deviation. The only difference here is your deviation will be unknown and you move it across and find it at the last point. So the three things we need to be able to find an unknown mean or unknown deviation is we need to know what our z-score is, okay? And we need to do that. We need to find out by finding your inverse norm using your area, the tail, and a mean of deviation of 0 and 1. Once we've got that, we've converted the 0.2 into your mean score and our z-score, and then we just rearrange until we get our mean. And next video we're going to look at an example where we have both unknown mean and unknown deviation. Good luck.